Yeah.
All right, so we're gonna start off with centripetal force today. We had discussed all the basics of circular motion, the formulas of angular velocity, acceleration, uh, and angular displacement in the previous lesson. All right, centripetal force. So I gave a hint of what centripetal force is in the last lecture as well. Considering you're circular motion here, once again, let's look at this. Now, for this circular motion, assuming the object is moving, let's say in this direction here. So moving in a circular motion, object always has a steady speed, a constant speed. So these are the established facts. Constant speed. अच्छा इसके बाद because the direction is changing at every instant, remember we talked about how you can draw tangents at different points in a circle and then see the direction of the object at that particular instant. Because it's a circle, so direction changes at every instant. All right, so because the direction changes, the acceleration will also change, right?
Yes.
Direction changes. Due to this change in direction, number one, velocity will change. All right. So we can also state that velocity changes. And now because the velocity changes, the acceleration would also be there, or acceleration would change. So we can write that acceleration changes. Why? Because you can look at these basic formulas to establish the relationship. For instance, v minus u by t is acceleration. Delta v over t is acceleration. If delta v increases, or the change in velocity increases, the acceleration also increases. There is a directly proportional relationship between velocity and acceleration. This is how we can conclude that acceleration will increase or change if an object moves in a circular motion. Now, you see, there's a reason why this object is moving in a circular direction. I mean, there's this force that's acting inwards towards the center, and it's keeping the object move in a circular motion throughout this path. If you remove this force, the object would continue moving in a straight line path following Newton's first law. So even theoretically, if you look at these changes that we've just written, a change in acceleration means that there is a resultant force present. Why? Because F is equal to ma. This is Newton's second law. So Newton's second law states that a resultant force is equal to the product of mass and acceleration. If there is acceleration, there is always a resultant force present. Because considering the mass is constant, acceleration responds to force. All right. So we've just stated that the acceleration changes. Therefore, there is a resultant force present. And where is that resultant force acting? It's acting inwards towards the center of the circle. And that resultant force is basically the centripetal force. Centripetal force is basically the force that acts inwards towards the center of the circle, keeping the object move in a circular motion. Clear up till now?
Yes, clear.
Okay. Because it is a resultant force, we call it an unbalanced force as well. Obviously, the force isn't getting cancelled out, so it is unbalanced, the resultant. As soon as you cut off all the forces, again, circular path, assuming the object is over here, and the force is acting like this towards the center. If you, let's say, remove this force, the moment you cut this force off, the object would continue moving in a straight line. Why? Because an object only acts in a circular motion whenever there's a resultant force, there's an unbalanced force. All right, so straight line motion takes place when there is no resultant force, no unbalanced force on the object. All right, do you remember Newton's first law?
Yes.
Can you recall it for me?
that the object will continue its state of motion until or unless a resultant force is applied to it.
Exactly. So assume that this, let's say this object was initially moving in a straight line. As soon as the resultant force started acting on it, the straight line motion was disturbed and the object started moving in a circular motion. So this is how Newton's first law falls true over here. So assuming, now let's put it in a real life situation. Okay, you have a stone attached to a string maybe, and this is where you're holding the string from, and this is tension acting on the string, and you're swinging the string like this in a circular motion. Okay, is तरह से. So the moment you cut your string off or you just leave the string, the stone would move like this in a straight path. It will just move away from the center, move away from you, because you're breaking the tension. This tension in this case is the centripetal force. All right, centripetal force can take up different forms. It's not necessarily a friction force, a tension force. It can be anything at all. Anything that basically keeps the object moving in a circular motion. We talked about this example of cars moving on banked road surfaces. Remember in the last lectures, let's say if this is how a road is made and a car moves on this road, there's always going to be a force generating from between the tires of the car and the road surface, the force of
Frictional
friction.
force.
Yeah, and that frictional force would act inwards towards the center of circle. Now, in this case, friction is acting as a centripetal force. All right, centripetal force is just a label that we use to describe any force keeping objects moving in a circular motion. So what is the exact definition? From exam point of view, from the standard marking scheme, the definition of centripetal force is, you can note it down, a force perpendicular to object's tangential velocity acting inwards towards the center of the circle in a circular motion is known as centripetal force. Look at the keywords here. Perpendicular to the object's tangential velocity, circle. This is how a tangential velocity would be. A force acting inwards is always perpendicular, makes an angle of 90 degrees here. Acting inwards towards the center of circle. The second keywords. And the third set of keywords is in a circular motion. So you'll be marked on these words while writing a definition. This is where the students mostly get confused when they see definition questions of 3 marks. Ab definition mein 3 marks kahan se lekar aayenge? It's all about the keywords that you write in your definition. Okay? You need to use those scientific terminologies while explaining a scientific term. So this was the definition of centripetal force. If you've noted down, we can move forward.
Yes, continue, sir.
Okay. Let's look at a few examples of centripetal forces. Number one, tension. We just looked at the example of how a tension in a string would act towards the center.
Then a car taking a turn.
A car taking a turn is force of friction. Yeah, so friction between the road and the tires of the car. Third could
Can
be
we take the example of the Earth orbiting around the sun? The gravitational forces
definitely
can be centripetal force.
gravitation. I was about to write that. Gravitational force. It's basically the planets moving in the solar system. The force that keeps the planets moving in an orbit. And the fourth one, look at the electrons, how they move around the nucleus. There's electrostatic
Electrostatic
force.
force.
Yeah. So considering this as the nucleus, these are the electrons. So electrons, because they orbit around the nucleus, there's an electrostatic force of attraction that keeps the electrons moving in a circular motion, and this is the centripetal force. Okay. Now, you see, there's an acceleration because of this force. We've established this fact. This acceleration produced by the centripetal force is called centripetal acceleration. So we're looking at the concept of centripetal acceleration now. Now, this acceleration is produced due to the centripetal force. And the formula for centripetal acceleration is v square over r. Let's see how we can derive this formula. So, assuming this is a circular path, this is point A where the object is placed initially. This is point B, and you're moving from A to B. This is the angle that's basically covered the angular displacement, and here's delta V. This is theta. Okay. So we know from in moving from A to B, the angle changes by theta and the velocity changes by delta V. So can we say that theta is equal to delta V over V? And so we're supposed to derive this formula here, V square over R. Now what we can do is let's include time, because obviously हम इसको acceleration तक इसी तरह से लेकर जा सकेंगे if we introduce time in this equation. And what you can, yeah, you divide time on both sides है. उससे क्या होगा कि आपके पास एक तो आ गया, अगर आप हम इसको रीअरेंज भी करते हैं, let's just take v on this side, तो आपके पास टाइम सिर्फ नीचे बच गया, तो it's v delta q over delta t is equal to delta v over delta t. Okay. Acha. This is acceleration, yeah, delta v by t. So you can simply write acceleration underneath this. And if you notice, delta, this angular displacement over time was omega. We studied this in the previous lecture. Omega is delta q over t. So we can replace omega. And अच्छा, अब ये है कि t भी चला गया, पीछे v बच गया, तो v omega आ गया यहाँ पे हमारे पास. And because omega is v over r, so instead of omega, we can write v by r, so v squared over r. So a is v square over r. This is how the formula is derived. I don't think you'll get a lot of questions on this derivation, but just know okay, how are we ending up with this one here. Now, since we already know acceleration is v square over r in this case, so when we consider Newton's second law here, F is equal to ma, so the acceleration that we talk about with this particular formula is the centripetal acceleration, right? So we can substitute the formula of centripetal acceleration for this one here.
So
F is equal to, yeah,
m into v square over r.
Yeah. So this is another formula for centripetal force, mv square over r. Or if you want to, let's say, substitute v omega once again in the equation, so v square over r could also be written as mr sorry, mr omega square. तो f is equal to mr omega का square बन गया over r आ गया. तो basically you're getting mr omega square f. So we've derived these two formulas. F is equal to mv square over r and f is equal to mr omega square. These are the two formulas for centripetal force. Any questions so far?
No, it's all clear.
Okay, great. So, अच्छा, हमने भी बात की थी कि velocity, sorry, speed remains constant during circular motion. The question here is, why is the speed constant during circular motion? So, there are two reasons for this basically. Let's just get to the easier one. एक तो हमें पता है कि work done is force into distance or displacement in direction of force. So the fact here is that work done is equal to F into D, and D should be in direction of the force. In this case, distance is not moved in the direction of force, yeah? Although the force acts inwards, but the object takes a circular motion. So because the distance is not covered in the direction of force, work done is zero. Because you see, this is a condition for work done. The distance or displacement must be covered in the direction of force. So when there is no work done, so delta energy would also be zero. Kinetic energy is zero, right? And if, sorry, constant,
Right.
not zero, constant, constant. When the energies are constant, half mv square, yeah, this v should also be constant. This is how you can say that speed remains constant because there is no change in energy. Why? Because there is no work done. And that is because the distance is not covered in the direction of force. This is how you can take help from these equations to prove the statement that speed is constant. Moving on. Let's study the origins of centripetal force. You might not always have a very straightforward origin of a straightforward physical origin of centripetal force. But you'll obviously have to see the unbalanced forces. You'll have to see for resultants because resultant is most of the times the centripetal force. Assuming this is an object placed on a flat surface. Now let's look at the forces. Number one, this object's weight acting downwards.
The normal force.
The normal force. And then if we say that this let's say this cart is moving towards the left side.
Friction towards the right.
Friction. And if let's say it's moving at a it's moving forward, it's moving towards the left hand side. So obviously this force, the forward force, is greater than the friction force. This is the reason why the object is sliding towards the left hand side. So this is supposed to be the centripetal force, the unbalanced force. All right. Similarly, if this is the surface now, and let's work out the forces on this. सबसे पहले तो यहाँ पे weight act करेगा, then the normal reaction force. And now if you resolve AC force को
components.
yeah. अच्छा, तो अब इसमें अनबैलेंस्ड फोर्स कौन सी आ रही है? R sin theta, right? Because it has
Yes.
no resolved component on the other side. So R sin theta is supposed to be the centripetal force. Now you can use the equations of the centripetal force to further resolve this as well. For instance, R sin theta is equal to mv square over r, or R sin theta is equal to mr omega square. Yeah. So आगे अगर आपको values पता हो, you can use these equations to further solve this question. The point of making these diagrams is to just make you understand that any unbalanced force will be the centripetal force. In that case, you might not get a very straightforward force. You'll have to resolve. आपको खुद करना पड़ेगा थोड़ी सी working to get to the centripetal force. तो वो थोड़ी सी working करेंगे समझ आ जाएगा, पता लग जाएगा कहाँ पे force unbalanced है. इसी तरह से let's look at another example. For example, this is an aircraft. ठीक है, tilt हो रहा है थोड़ा सा. सबसे पहले तो यहाँ पे weight आ गया. This is the lift force. अब इस lift force को let's resolve. So you're getting this LF sin theta. This is your centripetal force. Okay, another example. Let's look at the case of a pendulum maybe. Now in this case, there's a tension force acting in the string of the pendulum. There's weight acting downwards. And then this tension will have its two components. Yeah. सबसे पहले T cos theta.
Tan sin theta.
So this T sin theta is the unresolved force. This is the reason why the pendulum would obviously be moving like this towards the origin. So यहाँ पे T sin theta is equal to the centripetal force, and you can further resolve it to T sin theta is equal to mv square over r, or mr omega square. Just hold on for a second. All right, so Let's look at some vertical rules of these forces. सबसे पहले तो for example, the object A is at this point and B is at this point. This is the center. In that case, acha, so यहाँ पे let's look at the tension first of all. The tension would act upwards towards the center from point A, and from point B, the tension would act downwards. These are the tension forces. So assume that this is a stone attached to a string and it's moving vertically. अब किस तरह से इसके अंदर at different positions of the stone, how will the forces change? So we're looking at A, position A. First of all, at position A, the weight would act downwards. The tension would act inwards towards the center. Similarly, when the stone is at position B, in that case, the tension would act downwards and the weight would also act downwards. So at point A, if we specifically focus on point A, at this point, the tension, because the stone moves in a circular path, obviously the tension is greater, right? So tension minus weight is equal to MA. Why? Because tension minus weight is the resultant force. So we're looking at how to resolve forces to get the centripetal force in this case. ठीक है, F minus FR is equal to MA होता है Newton's second law. So considering one as the opposing force and the other as the second opposing force, you're getting the resultant. Tension of A minus W is MA. If you want to further simplify it, you can write it as TA minus W is equal to mv square over R. And this could be your equation of centripetal force for this object at position A. Now, if we consider position B, tension in B will be added to weight because both of the forces act in the same direction is equal to MA. And then further resolve it to TP plus W is MV square over R. This is your equation for centripetal force for this object at position B. Clear?
Clear. तो सर कहते हैं अगर लाइक पॉइंट जो स्टोन है अगर वो बी से थोड़ा सा पोजीशन आगे हो मतलब कि डायगोनल हो तो फिर क्या करेंगे?
फिर अच्छा, अगर हम यहाँ पे अज्यूम कर लेते हैं और फिर भी यही बात होगी, फर्क तो कुछ भी नहीं पड़ रहा। नहीं, फिर वेट का कंपोनेंट आएगा क्योंकि वेट तो फिर यूं
वही
जाएगा ना।
कॉम्पोनेंट लेना पड़ेगा।
हाँ, टेंशन तो बिल्कुल स्ट्रेट चली जाएगी। आपको ये एंगल पता होगा तो आप उसको रिजॉल्व करके वेट का कंपोनेंट ले लेंगे सिर्फ, दैट्स इट। ठीक है,
ठीक है।
ऑलराइट। अच्छा, इसी तरह से अगर यहाँ पे टेंशन की जगह नॉर्मल रिएक्शन भी, ये भी हो सकता है कि आपको टेंशन की जगह नॉर्मल रिएक्शन गिवन हो, तो बात सिर्फ एक ही है। What if let's say this is the circle, this is position B, this is position A, यहाँ पे this is normal reaction force, this is weight, and then this is the normal reaction force, और यहाँ पे weight है, तो एक ही बात होगी यहाँ पे NA minus W is equal to MV square over R for position A, and for position B क्या होगा, NA plus W is equal to MV square over R. Same thing with different names, all right? And there is a chance that the stone might snap at A. Why? Because A पे the weight is acting downwards and the stone might just break away from the string. तो ये आपको basically यहाँ से पता लग सकता है. Alright. अब ये करते हैं, let's look at an example question. ताकि whatever the theory that we've studied, we should know how to apply this practically as well, or the exam type questions that you can expect in paper number 4. So I'm gonna, I'll also provide you some resources for paper practice. As soon as we get done with topics, you'll have to obviously be practicing different questions, and then we'll have discussion sessions over those questions as well. But for now, let's just look at this example question. For example, here's an aircraft. इस पे the way it is acting downwards. Hassan, you can keep a notebook and you can also solve this question side by side. Diagrams भी draw कर लो, ठीक है? This is left force. अब यहाँ पे this is force P. So basically, an aircraft is moving in a horizontal circle. Two vertical forces act on P, the left force and W. I've already drawn these two forces. It is moving with a constant speed. So the speed of this aircraft is 250 meter per second and has a mass of 4 times 10 raised to the power of 4 kgs. This is P, this is 35 degrees, this is the angle between the vertical force, left force and P, ठीक है? Weight आपको given है. तो जो first part है, वो ये है कि vertical component of P. कैसे मिलेगा vertical component of P? Simple resolution है towards this side, P cos theta. So P cos of 35 is equal to W because W will be the opposing force in that case. Yeah, this is where P cos theta is. And W, it's acting upwards, W is acting downwards, so you're going to equate it to W. W is supposed to be mass times gravitational force. Mass is 4 times 10 to the power of 4 kgs. So P cos 35 is equal to 4 times 10 raised to the power of 4 times 9.81. ये जो further calculation है, you'll do this if you're asked to calculate P. So we're assuming you're also asked to calculate P at this point. So you're going to simply use this equation of P's component, P cos 35 is equal to W. You'll plug in the values of mass and gravity, और फिर आपको आंसर मिल जाएगा. तो this is P is equal to 4 times 10 to the power of 4 times 9.81 over cos of 35. You can use a calculator here. Hassan, can you tell me the answer for this?
Sir, the power is 4, right?
The power is 4, yeah.
It's 479,031.
477,031.
79,031.
Newton. You can round it off to 479,000 newtons to 3 significant figures. Okay. Now, for the horizontal component of P.
It will be P sine theta.
Yeah. P sine theta is equal to nothing because you know the P now. तो आपको बस इसका आंसर मिल जाएगा. तो 479,031 sine 35. Can you also calculate this?
So it's 2. Wait, let me, can I type it?
Two seven four seven six. Hold on, my whiteboard just got stuck. Anyways, I think it's working now. 274,761 rounded off to 275,000 newtons. This is the horizontal component of P. Now, if you're asked to find acceleration, You'll simply use F is equal to ma. हमारे पास the force is 275,000. You're going to take the horizontal component of acceleration here. Why? Because we're talking about the centripetal acceleration. Yeah. So 275,000 is equal to mass is 4 times 10 to the power of 4 times a. So 275,000 over 4 times 10 to the power of 4 is acceleration. इसका आंसर आएगा
6.87
6.87 meter per second square. And now you've got the acceleration as well. What if you're asked to find the radius of the circle as well? Just circular motion में move कर रहा है. तो radius and acceleration को एक equation relate करती है, that is v square over r. Acceleration is 6.87 over v square. v आपको शुरू में given था 250. 250 whole square is equal to r. So इसको resolve करने के बाद आंसर आएगा 9100 meters. This is the radius. You see how we started off from the basics of component resolution, then to the acceleration, and then to the radius of the circle. So we've sort of exercised all of the formulas of centripetal forces and centripetal acceleration here in this question. Any questions?
No, it's all clear.
Can you end the recording now?